Okay. So problem statement: cantilever AB 2 meter long is carrying a load of 20 kilonewton at free end and 30 kilonewton at a distance 1 meter from the free end. Full stop. Find the slope and deflection at the free end. Take E as 200 Gpa, I as 10 raised to 6. I it is, sorry, this value it will be, just I will write down this value. It is given 150 into 10 raised to 6. So I it is 150 into 10 raised to the power 6 mm raised to 4. Okay. So first of all, this EI it is converted, it is in kilonewton meter square. So first E is equal to, it is given, E is equal to it is 200 GPa, 200 GPa. So convert it is in Newton per mm square. So 200 into 10 raised to the power 3, it will be getting Newton per mm square, Newton per mm square, Newton per mm square. Okay. So next one, it is moment of inertia. I it is given, I is equal to it is 150 into 10 raised to the power 6 mm raised to 4, mm raised to 4. Okay. So calculate EI. EI is equal to it will be 200 into 10 raised to the power 3 into I it is 150 into 10 raised to the power 6. Okay. So it will get this value. So 200 into 10 raised to the power 3 into 150 into 10 raised to the power 6. So it will be 3 into 10 raised to the power 13 Newton mm square. Newton mm square. Newton mm square. So convert this one, it is kilonewton meter square. So EI is equal to, actual value it is 3 into 10 raised to the power 3, 13 Newton per mm square. So we need to convert it is in kilonewton meter square. So first of all, 1 Newton 2 kilonewton divided by 1000. Okay. Then now mm to meter square, that is mean 1000 square. 1000 square. Okay. 1 meter is equal to 1000 mm square. It will be 1000 square. So all this value to be get in kilonewton meter square. So divided by 3 into 10 raised to power 13 divided by 1000 into 1000 square. 1000 square. Okay. So it will be get 30 into 10 raised to power 3. 30 into 10 raised to the power 3 kilonewton per meter square. Kilonewton per meter square. 30 into 10 raised to the power 3 kilonewton per meter square. Okay. So I will note down this value. EI is equal to 30 into 10 raised to the power 3 kilonewton per meter square. Kilonewton, sorry, per not. It will be kilonewton meter square. So unit it is wrong. Written wrong unit. Okay. It will be is equal to 30 into 10 raised to the power 3 kilonewton meter square. Kilonewton meter square. Okay. So this one it is 30 into 10 raised to the power 3 kilonewton meter square. Okay. So now second step. So consider this section XX. So this one it is consider section XX at a distance x from free end. That is a distance x from free end. Okay. Write down now. So here we have calculated. Second step. Consider section XX at the distance x from free end, x from free end. Okay, x from free end. So say section xx at a distance x from free end. Okay, so now moment at xx, moment at xx, moment at x. Okay, so here, so clockwise it will be take positive, anti-clockwise it will be take negative. If the moment it is, just I will this, if moment it is clockwise, it will be take negative. If moment it is clockwise, anti-clockwise, it will be take positive. Okay, take positive. Okay, because section it is left side, xx all the load it is in, sorry, right side, all the load it is in right side. So that's why we are assumptions when it is clockwise direction it will be take negative, when it is anti-clockwise it will be take positive. Okay, so here moment at xx is equal to, so first of all this 20 kilonewton it is rotating clockwise direction, so minus 20 into x, then minus 30 it is also rotating clockwise direction about the a. Okay, so this distance it will be, how much this distance, so this distance it will be x minus 1. Okay, here this distance it is x minus 1, x minus 1. So that's why we will write here in bracket x minus 1. Okay, so this one it is also rotating. How it is rotating? It is in anti, sorry, how it is rotating? It is in clockwise direction rotation. So that's why clockwise it will be negative value. So that's why I written in front of 30 it will be minus value. Okay, so now Macaulay's method, apply the Macaulay's method. ei it is d2y by dx square, d2y divided by dx square, d2y divided by dx square is equal to moment. Okay, is equal to m. Okay, mx. Okay, so now write down all this here. ei d2y by dx square, d2y divided by dx square, dx square y by dx square is equal to moment at xx minus 20 into x, then minus 30 in bracket x minus 1, x minus 1. Okay, so I will write here. Now we can write down, so integrate above equation with respect to x. Okay, so this equation we will need integrate. So after integration ei, so d2y by dx square it will be dy by dx, dy by dx is equal to integration of 20x, so it will be minus 20 into integration of x, it will be x square by 2, it will be x square divided by 2, x square divided by 2, then minus 30 in bracket x minus 1 integration it will be, you can write down x minus 1 square, x minus 1 square divided by 2 plus c1 okay, constant. So just simplify this equation. AI bracket in dy by dx, dy by dx, dy by dx, dy by dx is equal to minus minus. So this one it will be 2 1s are 2, this one 2 10s are 20. So minus 10x square minus 10x square 10x square 10x square. So 2 1s are 2, 15 2s are 30. So it will be minus 15 into in bracket x minus 1 bracket square, x minus 1 bracket square then plus c1 plus c1 plus c1, okay, plus c1. So this one it is, write on this one, you can write on this one, it is equation number 1. Equation number 1. So again integrate with respect to x, write on. So we'll write on again integrate with respect to x, So ei dy by dx it will be get y is equal to, so now minus 10 x square, it will be integration of x square, it will be x cube by 3, it will be x cube by 3, x cube by 3, integration of x square, it will be x cube by 3, then minus 15 x minus 2 integration x minus 2 bracket square x minus 1 bracket square, the integration of x minus bracket square, it will be x minus 1 cube divided by 3 then plus integration of constant, it will be c1x, then plus again c2, okay, c2. So this one it is equation number 2. So now apply the boundary condition. So I will write down here. Apply first boundary condition. When x is equal to 0, when x is equal to 2 meter, so dy by dx is equal to 0. Put in equation 1. Okay. So when dy by dx it will be 0, so this term it will be 0 is equal to, so minus 10 into x square, it will be x square, how much x square, it will be 2 square, then minus 15 in bracket x, it is 2 minus 1, how much it will be, 2 minus 1 1 square, okay, 1 square, then plus c1 so 1 square it will be 1, okay. Now write down c1 square, it will be 10 into 2 square, it will be 40 plus 15, it will be 55, okay. So c1 is equal to 55, okay. C1 is equal to 55, okay. C1 is equal to 55. So now apply second boundary condition. We will write on here. Second boundary condition. When x is equal to 2, when x is equal to 2 and y is equal to 0. Okay, y is equal to 0 because the curve of this beam, it will be like this one. Okay, so slope and deflection at A, it will be 0. Okay, when x is equal to 2 meter, so x it is measured from B distance. Okay, so when x is equal to 2 meter, so slope and deflection at A, it will be 0. Okay, so put in equation 2. Put in equation 2. Okay, put in equation number 2. Okay, so here y0, it will be 0 is equal to minus 10 into x square is equal to 2. 2 cube divided by 3. 2 cube divided by 3. 2 cube divided by 3. 3. Then minus 15. Minus 15. X is equal to 2. That is means 1 cube. 1 cube divided by 3. 1 cube divided by 3. 3. Then C1 it will be, we are calculated C1 it will be 55. 55 into 2, then plus C2, then plus C2. Okay, so from this relation it will be get C2 value. Okay, C2 value I will write down here. 0 is equal to, so 2 raised to 3 divided by 3 into 10. 26.67 minus 26.67. Then 3 5 is a 15, 5. Then minus 5. Then plus 15 into 55 into 2. So it will be 1110 plus C2 plus C2. Okay, from this relation it will get C2 is equal to minus 26.67 minus 5 plus 1110. So it will be get C2 value, just I will cross check C2 value 78.33. So this one it is minus 78.33. Okay, so this one it is C1 C2 value put in equation number 1 and 2 and write the slope and deflection equation. Okay, so now you can write here. Okay. Put C1 C2 value. So this one it is equation number 1 and 2. Put C1 and C2 values in equation 1 and 2. In equation 1 and 2. 1 and 2. Okay. First of all, write down equation number 1. EI dy by dx 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 is equal to minus 10x square minus 10x square 10x square minus 10x square, then minus 15 in bracket x minus 1 then plus c1 value it is 55. C1 value it is 55. So write down this one, it is equation number 3. Equation number 3. Okay, equation number 3. Okay, so now put equation number 2, C1 and C2 value. Okay, so equation number 4 it will be write down EI into y is equal to minus 10 x cube divided by x cube divided by 3, x cube divided by 3, cube divided by 3, cube divided by 3, minus 15, 15 in bracket, x minus 1, x minus 1, cube divided by 3, minus 1, cube divided by, divided by, divided by 3, divided by 3, then plus c1, c1 it will be 55x, x, then c2 value it will be 78.33, 78.33. So this one it is equation number 4, equation number 4. Okay, equation number, so this one it is equation number 3, it is slope equation, and equation number 4 it is deflection equation. Okay, so we need to calculate first slope at free end. Okay, slope at free end, slope, slope at free end, slope at free end. Okay, slope at free end, so put x is equal to 0 in equation 3, that is equation number 3 means slope equation, you can say it will be slope equation also. Okay, so ei slope equation, ei dy by dx it will be, and dy by dx is equal to theta b, you can say it will be theta b, slope at b. Okay, theta b. Okay, theta b, so theta b is equal to, 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 so minus 10, x it will be 0, so this term it will get 0. Okay, and second one it is minus 15 x minus 1, so minus 15 x it will be 0, 0 minus 1, so this term it will be take 0, when we will get negative value when in bracket it will be take terms this 0, so only it is 55, 55. So theta b is equal to, you can write down theta b is equal to, theta b is equal to 55 is equal to 55 divided by ei. So ei value we have calculated, ei value we know that it will be, just I have noted this value, this value it is 30 into 10 raised to the power 3, it is 30 into 10 raised to the power 3. Okay, so it will get theta b, so 55 divided by 30 into 10 raised to the power 3. Okay, so it will be 0.001833 radians, radians. Okay, radians, so it is theta b. Okay, so slope at b it will be 0.001833 radians. Now calculate deflection at c, b, sorry. So now deflection at free end, free end. Okay, that is means b, at point b, at b. Okay, so put x is equal to 0 and y is equal to yb, yb is equal to yb in equation 4, in equation 4, in equation 4, okay, in equation 4. Okay, this one equation, I will write down here. So ei y it is yb is equal to, so this term it will be get minus 10 into x cube, this term it will get minus x 0, so 0 minus 1 cube, this term we will take 0. Okay, so then 55 x it will be 0. So this term it is also 0. So only remains minus 38.33. 38.3. Okay. So 38.33 yb is equal to, you can write down yb is equal to minus 38.33 divided by y ei, it is 30 into 10 to the power 3. 30 into 10 to the power 3. Okay. So 30 into 10 to the power 3. So minus 78.33 divided by 30 into 10 to the power 3. It will be minus 2.611 into 10 to the power minus 3 in meter. Okay. So convert it is in mm. So yb is equal to, convert it is in mm. It will be get multiply by 1000. It will be minus 2.611 mm. So minus indicates, so deflection is downward direction. Okay. Deflection, it will be downward direction. See here, this will be deflection, it comes in downward direction. Okay. When you one end fixed and other end free, if you apply force at free end, so deflection, it will be comes in downward direction. Okay. Hogging type bend should be occurring that way. Okay. So this is hogging type bend, means at the free end, so deflection, it will be maximum. Okay. So deflection at free end, it will be maximum. Okay. So that's deflection, it is minus 2.611 mm. Minus indicates the deflection, it is in downward direction, it is acted. Okay.